Yeah, my voice is audible. PPT is also visible, right?
Yes, sir.
Yeah. Last class we discussed about compatibility or continuous equation, and after that we discussed about compound stresses. Yeah. So directly I'll go for compound stresses. Compound stresses are nothing but the two or more stresses induced in a component, right? Two or stresses induced in a component, then the component subject to compound stresses. When the component is subject to two or more stresses, so 1 minute is a bad network quality. So please inform me whenever my voice is not audible. Please inform to me. Okay. Now my voice is audible. Is give me response.
Yes, sir. Yes, sir. Audible, sir.
Now PPT is also visible.
Yes, sir.
Yes.
Yes, sir.
Yeah. What is the name of the PPT? Yes.
So it went, sir. Wait.
What is the name of the PPT?
Stress is acting on inclined plane, sir.
Inclined plane. Yeah. Okay. Thank you, Ma. Now we discussed about compound stresses. When a member is subjected to two or more stresses, then we can say that the member is subject to compound stresses. When two or more stresses are acting on a member, now you can see then the figure, first figure, if the body is placed in an inclined plane, when a body is placed on inclined plane, due to the weight of the body acts vertically downward, right? That is W is equal to M into G. Now what we will do, we will go for resolve that component, resolve that weight of the body into two components. One is a perpendicular to the plane, another one is parallel to the plane. If a force is perpendicular to the plane, that force is called as a normal force, and whatever the stresses induced on the normal plane is called as a normal stress. There's a one stress component is acting on the body. Second one, we need to draw the a parallel to the plane, that is called as the force is parallel to the plane or on the acting on the tangential to the surfaces, then that force is called as shear force. The shear force generated over the cross sectional area, the over the surface area, that will get shear stress. This is another stress components acting on the body, acting on this plane, right? Then we can say that the body is subjected to, that is a what body here, this is the body, that is the acid one is the no, that acid one, that is for the body is subjected to two for stresses or two forces. One is normal component, another one is shear component. Means that normal component produces normal stress, shear component produces shear stresses. Then when the body is subjected to two or more stresses, then it called as a that body subject to what type of stresses? Compound stresses. That's the best example. You can see that the compound stress acting on a body. What type of body here? That is an inclined body or inclined plane. You can see the two or more stresses acting on a inclined plane. That is the stresses acting on inclined plane. Now, some other example for where you can see that two or more stresses acting on the body means we can take a shovel. When you insert the shovel over the mud or a sand, you can see that how many stresses are developed here. One stress is acting vertically downward, other two stresses are acting another the direction, horizontal direction. Similarly, take an axe. When you go for cut the wood, the axe is a what type of shape it is? Is an inclined plane. If you take a knife also, knife is what type of plane it is? It is inclined plane it is. The stresses acting on the inclined plane that produces a compound stresses. Two or more stresses acting on that plane. Similarly, go for chisel and hammer, or if you take a, these are the simple machines. You can see that all of these mechanical members or engineering components are subjected to two or more stresses. That's what we go for study here. When body is subject to two or more stresses, our aim is to determine what will be the maximum stresses induced in the body and where it is induced. Okay, those things we are going to determine here. For a best example, if you take a bar, okay, consider this is a bar. If an axial load acting on that bar means only one load is acting here, then what type of stress you get? Only one stress, the normal stress acting on the component. Then you can easily determine what will be the maximum stresses induced in the bar. A bar is subject to an only axial load means throughout this length, you can pass an arbitrary cutting plane. There is a perpendicular to the axis. That will be the maximum stresses induced in the plane. Throughout the length, where is the location? Throughout the length will be the maximum stresses are induced. That is what its quantity sigma is equal to P by A. That is for simple stresses you can easily determine what are the stresses induced or the magnitude of stresses induced and what will be the maximum stresses induced in the component. That you can easily determine in the simple stresses. Means a bar only one stress is acting on the component means one stress is acting on a member means you can easily determine what will be the maximum stresses induced in the component. Similarly, if you go for a two or more stresses acting on the component, then I want to determine what will be the maximum stresses induced in the component and where it is induced. Then we go for follow the some procedure and go for the derivation also. Yes, for that what we will consider, we will not consider a three-dimensional component. We consider a two-dimensional component, that is a plane stress system. Okay, we'll consider only on the surface of the component. For three-dimensional, again it is somewhat different. It is for our subject point of view. We'll discuss only a plane stress means two or more stresses acting on where? Acting on the plane means two-dimensional component. These are some of the examples. You can see that a torsion bar or a bending of a beam. Those are subject to how many stresses? Two stresses, right? Two or more stresses acting on in the torsion bar. Only two stresses are acting in the bending of a beam. Okay. Next, that also called as the compound stresses or the stresses acting on an inclined plane. Most of all the structural member, machine component or aircraft structures or any engineering component it can take, those are in three-dimensional in nature. Then when a body is subjected to several loads, that produces several stresses. Once several stresses are acting on a body, three-dimensional body, now what we will do, we will go for determine what will the stress at a point. For that, we will go for pass an arbitrary cutting planes or arbitrary a parallel planes. You are going to apply. So we'll go for cut that component and then you make it a cuboid. Once you cuboid, then you know that what are the stresses acting on that point at a particular point or an element, cubical element. Then again, we go for convert, go for take the advantage of the geometry. Now we'll consider thickness of the element is unity, means 1. Then what will you convert here? Three-dimensional component to a two-dimensional component. You can see in the figure number 2. Is a 2D plane stress acting on the element.
943.
Now what are these? Sorry. Yes, what are the stresses acting on this two-dimensional element? So two normal stresses, sigma x, sigma y, and one shear stresses, that is a tau xy or tau yx. Both are same. This is a complementary shear stresses. Total 3 stresses are acting on a two-dimensional element, such as sigma x, sigma y, tau xy. These stresses are called as a component stresses. Now, what we call as a component stress means those stresses acting along the coordinates, along the x component or x coordinate. Another one is along the y coordinate or y component, that is sigma y. Along x component, normal stress is sigma x. Along y coordinate or y axis, what is the normal stress is sigma y. On x plane, y direction, or on y plane, x direction, that is the shear stress is acting on x plane y direction, that is a tau xy, right? Those are called as a component stresses. Now, once you consider component stresses acting on the member, acting on an element, okay, now what our aim is? Our aim is here, see, consider an element or a point in a body subjected to various stresses, means two or more stresses acting on the body. To find the stresses induced, what are the stresses we are going to induce here? One is a normal stress, a stress which is perpendicular to the plane, and another one is shear stress. Shear stress means a stress which is acting parallel to the plane, acting on an arbitrary plane, cutting plane. From these stresses, it can be find the magnitude of maximum normal stress. What is the maximum normal stress acting on induced in the component or an element, and maximum shear stress induced in the element. And its orientation means the location where exactly the maximum normal stress and maximum shear stress acting on the component. Then how do you solve this? We go for two methods. One is analytical method by applying exact formulas. Another one is graphical method. With the help of geometrical instrument, you go for construct it. That is, graphical method is also called as a Morse circle method. Okay. Now we'll go for determine the maximum normal stress and maximum shear stresses and this orientation. Okay, by analytical method. How do you solve this? For that, we'll consider a square element of unit thickness. The thickness of the element is 1. For that element, the square element is subject to a general stress system. When we say general stress system is that element subjected to a sigma x, sigma y and tau xy. Then we can say that the two-dimensional element is subject to a general stress system. Clear? For example, if you take the element is subject to uniaxial system. Uniaxial stress system is the stress acting only along the x-axis. You can see the camera, the stress acting only along the x-axis. That is